is something that I would pay really heavy attention to because scopes is one of those things that you really can't avoid in JavaScript, right? Like you could say like, hey, I never want to use a for loop, but that'd be kind of silly, right? You can say like, I never want to use booleans, I never want to use this, or you can avoid using it. Scope is not one of those things because scope is kind of built into the very fabric of JavaScript, and it's there every time you write JavaScript, whether or not you want to use it. So make sure that you actually like really understand this because if you don't, it's going to trip you up in fairly unexpected ways. Okay, so what is scope? Scope is the short definition on the board. Is it refers to which variables can be accessed at a given place in the code. What that means is yesterday when we were talking about error messages, one error that we saw was called reference error, right? It's like saying, hey, you're trying to use a variable that you haven't created yet. The two main reasons for why you had that error is one is you legitimately did not create that variable, right? You're trying to use something that does not exist. The second and more common reason why you get that error is because you're trying to use a variable that isn't accessible from that place, right? So even though the variable exists somewhere else on the page, where you're currently trying to use it, it doesn't quite exist. The way to think about scope at the end of the day is almost like a sandbox. And when you look at a piece of JavaScript, what you're really seeing is a collection of sandboxes. In every in each sandbox is a list of functions, a list of variables, a list of things you can do within that sandbox. And so today what we'll talk about is how we create that sandbox and kind of what the limitations are of using things within those sandboxes. So something that should be very straightforward now, right? I create a variable called wow, and I can console log it right away. There's no like limitation here because notice how on line 4 I create a variable, and on line 5 I'm using it, right? Like, and in this case, what we're talking about is this idea of a global scope. The global scope is like kind of like the outermost layer. The global scope is kind of like the parent, like the head, like the very top, right? If you think about it in terms of like a hierarchy, you might have like a bunch of small sandboxes in a park, but the park itself is a global scope, right? Like everything belongs to the park. So therefore, on the global scope, the idea is that the global scope is the outermost layer of the scope. Anything on the global scope is accessible to everything else. What does that mean? Okay. So what does that mean for global scope? The way that scope in JavaScript works is it follows like a very like family oriented relationship. And so what that means is when we have these sandboxes within bigger sandboxes, within every sandbox, you have access to all of the things that were created, all of the variables that were created in that sandbox, as well as all of the things that were in that parent's sandbox, as well as all of the things that are in that parent's sandbox, and going all the way outwards until you get to the outermost layer, which is called the global scope. And so when we talk about putting things in the global scope, what that usually is a euphemism for is the idea that anything on the global scope can be used by anything else on the page at a given time, right? So if I have something called a global variable, it really means it doesn't matter where I am in this JavaScript or on this page. No matter where I am going to have access to this global variable, right? Global means every single location on this page can read that variable, right? So if I have something like this, on line 6, I create a variable called global, right? And then I console log it out on line 8. That works perfectly fine. On line 10, I have this function called fun function. And on line 11, what this fun function does is it also console logs out this global variable. One really quick distinction that I'll make here that may be a bit of a sidebar is lines 10 through 12 does not do anything when I first create it, right? It creates a function. It doesn't run it. This function is actually being run on line 14. The only way to run a function in JavaScript is to have the name of the function followed by the open parentheses and eventually a closed parentheses depending on how many arguments the function takes. Okay, so and this will probably won't be the first time I say this, but just because a function is defined here does not mean it's being run, right? If line 14 did not exist, this function never ever gets called anywhere. It never runs, it never gets triggered. Just by defining a function does not mean you run it, right? We only run a function when we invoke it, and the only way to invoke a function is through the open and closed parentheses, okay? So when you see a function being defined, don't confuse that for the function being run, because those are two very different things.
Even without line 14, it still won't run the console log?
Even without line 14,
Without line.
fun function never runs, so line 11 we never reach line 11, ever. Okay?
Oh,
Yeah.
What if you return it? What if you return it instead of the fun function? Does that invoke it, or does that you have to put the fun?
No, it doesn't. And we'll talk about like what it means to return a function on next Saturday. But just know that for any given function, unless you see the open and closed parentheses after it, it is not being run.
Do you always have to return it, or can you just invoke it?
You can do either one depending on what you want to do. Yeah. Usually, so the way that return works in JavaScript is think of return as like handing in something or giving something to someone, right? Like, I don't know, what is a real world example of something you invoke? I'm trying to think of something right now. A command. A military command.
Elevator, you press a button, it comes to you.
Yes, but it doesn't work for the analogy I'm thinking about right now. I guess the idea is that like I mean, it sounds really dumb. Let's think of like a Jack in the Box, right? Like those wind up things where you wind enough times that something like a scary clown pops out, right? Like let's think of like the scary clown popping out as like us actually using the box, right? I can give the box to someone, not wind it up, and the clown won't pop out, right? So that's what returning a function is. Returning a function is just giving something from one location to another location, from one starting point to another endpoint, right? That's what return does. Invoking is like, hey, let's actually use that thing, right? So when we talk about invoking functions, right, line 10 through 12 basically says, here's a box. Line 14 says, hey, let's use that box, right? Otherwise, if we never wind up that box, if we never use it, that box just sits there and it's never used, right? So all I'm saying here is that like the only time that box is ever used is when it's in the analogy when it's wound up. But in JavaScript, that box is only ever used when you see this open and closed parentheses following it, because that's when you're actually using that thing. Returning is just moving something from one place to another place. It has nothing to do with actually using that material.
So to build on your analogy,
Yep.
if you give, okay, so the box exists, the giant box exists. You call fun function.
Yep.
So when you call fun function, you wind up the box, and then the scary clown pops out. And that clown is the contents of the function.
That's the process.
Yeah, more or less. Yep. Yeah. So what that function does is a completely separate discussion. But all I'm trying to say is that like the clown will never pop out unless you actually wind it up, and the winding up is the invocation part, which is different from like the here's a box part, right? Because here's a box is separate from here's winding it up. Patricia.
Trying to think about how I want to ask this question.
Yeah, go ahead.
Because the console log always prints something in that
Yep.
little screen, right? So you're not actually going there unless you say the fun function. But so you're just defining it, but then console log will. I don't know how to ask this.
Sure.
If you say return, it won't show anything on the screen, but the console log will show something on the screen.
Yeah, so console log is something that's primarily used for humans, right? It's meant to like basically make the code more readable or easier to understand for human beings, right? Unless you're invoking code in console log, which almost never happens, and you should never do. For the purposes of our class, let's just say that using console log doesn't invoke anything for now. Okay. The reason why console log has an open and closed parentheses here is because I mean, like the very rudimentary explanation here would just be that console log itself is a function, and this function says print this text on the screen, right? And so console log basically says give me a list of things you want me to print to the screen for you, right? It doesn't inherently invoke anything. So only use console. So like I got a few questions over the past day and a half about like should I use a console log or a return? Well, console log is meant for humans to read. If you want the computer to do anything with the code, it's always a return. Console log is only for humans, right? A console log code, a computer will print it out for you, but then it will disregard it right away.
Does the return show anything on the screen?
A return will. So.
Or is it like internal, like the computer's doing its thing with the return?
Yeah,
How
so
do you-
the more like nuanced explanation here would be that a return statement, like the screen will show the last thing that's being returned, right? So if you call like 10 functions in a row and each function returns something, you will only see the return of the very last function. And typically speaking, like I think I talked to most groups about this, right? When you use a return, what you're really saying is, hey, my function's done. Here's the very last thing that you will see, right? It's the reason why return is usually the last line in a function, right? Because after you return something, nothing else it does matters, right? The analogy I used yesterday was like, imagine you have a final paper, right? The paper is the thing that you turn in. Once you turn that paper, nothing else you do really matters, right? So unless you're ready to kind of end everything and hand in your test or hand in your paper, don't use a return. What that also means is you're only allowed to return one thing. Like each function will only be allowed to return one thing, and so that's why like if you have multiple returns in a row, the screen is not going to show like everything you've returned. It will only show the last thing that you returned. Um, and I would also probably not get too like at this stage it's hard not to, but I would not dwell too much upon what shows up on the screen. And the reason why is because the screen, once again, right, it's meant for humans to see and understand the code, but the computer and the mathematical work that's doing is happening regardless of whether or not you see it on the screen. So just because something isn't printing out on the screen, it doesn't mean like nothing's happening behind the scenes as well.
Yeah, quick question about
Rich?
returns.
Yeah.
Can you have multiple returns like within a function if they're contained inside like an if statement?
Yeah.
Yeah. So that's okay.
Feel free to have multiple returns, but just know that once the first return runs, nothing else after is going to run. So you could have like an if statement, have a return in it, have an else if statement, have another return in it, and maybe different things will be returned based on different scenarios. But once the first return hits,
No more returns.
Nothing
in that
else.
Iteration will go.
not any returns, nothing else after that will run.
In that iteration. Or
Right.
That function.
Yeah. So if I have a return statement followed by a console log right after it, the console log will never run. Because once the return hits, the function says, great, here's what you wanted, here it is, I'm done, right? And the reason why why the function does that is because, once again, the return is kind of like your final answer, right? Like once I give you that, nothing else matters. So why bother doing work that will never get shown? So return kills a function, and don't have a return somewhere unless in your mind you're like, great, once the function reaches here, this function is done. Okay, so quick sidebar, but back to this now, right? So once again, we have our global variable on line 6, right? And once again, we're creating it on the global scope. You can't see it, and really, but you can kind of assume that this is a global scope. Why? Because there's no other scopes around it, right? Like within this fun function, what we're seeing is within this fun function, we're actually going to create another scope, and we'll talk about that like in the next slide. But just know that because this is at the outermost level, there's no open and closed curly braces around this. This is the outermost scope, right? So global, this variable global is on the global scope, and when we print out this thing, on line 8, we print out outer, which is, and we feed in this global variable, which is ear. And so when we see here, we have outer space ear, okay? Inside this fun function, which we're running on line 14, we're console logging out inner, and we're also printing out the global variable. And we also have access to the global ear, right? And so the reason why this works, the reason why we're able to access this global variable from anywhere is because of the fact that, once again, in JavaScript, the way that the functions or the way that scope works is within this fun function, we have access to every variable created within this fun function, as well as every variable created in the parent scope of this fun function. What's the parent scope of fun function? It's a global scope. So any variable we create on the global scope, we also have access to it within this fun function. That's why we have access to that variable here, there. Yes, York?
It's kind of a special use case, but are global scopes so global that other scripts that you write can reach them? Like
Depends on where they're loaded.
Okay.
Is a short answer. It's yeah, that would be on a case by case basis.
Okay.
It's not like a universal answer for that.
Okay.
Yeah. Okay, so this is something that can be a bit tricky to understand, but just take me at the word. Take me at my word for now, and we'll come back to it like on one of the very last slides. Okay. When we define a variable here, we define this variable called wait for it. The way that JavaScript actually reads line 7 there is a twofold process. And this deals with the idea of something called hoisting, which we'll talk about later on. But for now, just kind of keep in mind that whenever we define a variable, JavaScript actually does two things, right? The first thing it does is it acknowledges that this wait for it variable actually exists. Like, hey, at some point I will have this variable called wait for it. The second thing that it will do is say, okay, great, and the value for the wait for it variable is a string called here I am. Okay. If I write lines 5, 7, and 9 in this order, when I first console log out wait for it, I'm going to get back undefined. And the reason for that is because what JavaScript does before it actually runs any code on your page is it does like one scan through first, and it'll say, okay, what are all the variables that are created in this scope, right? And so when line 5 runs, JavaScript has already gone through the entire page of code, and it's already acknowledged that the wait for a variable exists. It doesn't know what value it is just yet, but what it's also not doing is it's not throwing you a reference error. It's not saying, hey, you're using something that doesn't exist. It's saying, hey, you're using something that I know exists. I just haven't gotten around to figure out what it is yet. And so when you define a variable without giving it a value, by default, the value for that variable is undefined, right? Undefined is, once again, it's a data type. It's a reserved word too, right? It's a very special thing. But whenever you see undefined, it just means a variable was created, but its value had not been assigned yet. When line 5 runs and we console log out wait for it, we get back undefined. Then line 7 actually runs. And when I say actually runs, what it means is we've already acknowledged that this variable exists, but now JavaScript actually says, okay, what is your value? And here we say the value is this string called here I am. So after line 7 runs, when we keep going down to line 9, when we print wait for it again, we're actually going to get this string called here I am. Okay? And so this is just like a good rule of thumb is whenever you write JavaScript, what you want to do is you want to define all of your variables near the top of the function or near the top of the page, right? And it's kind of to avoid this very problem, which is that if you try to use a variable before the value for it is assigned, oftentimes you won't get an error. You'll just get probably like an unintended effect, right? In this case, the unintended effect is that wait for it is equal to undefined, when really you've kind of been assuming that it's going to be equal to the string called here I am. Okay, so that's kind of like a really quick primer on this idea of hoisting. And this is also why if you try to use a variable before you assign it, you won't get an error, but things might break down the road. When, like, let's say here we do console log wait for it, right? And beneath it, if we do wait for it dot length, then we'll get an error, right? If on line 6, if we print out wait for it dot length, we're going to get an error, right? Because we're trying to find the length of what? Of undefined, and undefined has no length property. So at that point, JavaScript will probably throw an error at you. But inherently, it won't throw an error because it's acknowledging that, hey, I know somewhere on this page you're going to create a variable called wait for it. Okay. Okay, so function scopes. Except for the global scope, all other scopes in JavaScript are created by the open and closed curly braces, right? So just so we're clear, curly braces are these squiggly lines. I tend to be very careful when I talk about things called like curly braces and parentheses and braces, because those three are very different things in JavaScript, and each one though has a very specific meaning, right? So they're not interchangeable terms. So scopes in JavaScript are created with only curly braces, except for the global scope. The global scope is just like the entire page, right? Like wherever you write a piece of JavaScript code, when the computer runs it, the computer actually adds like an opening curly brace to the very first line and adds a closing curly brace to the very last line on your behalf. You never see it, but that becomes like your ultimate parent global scope. Okay, so every other scope, especially the ones that you create, are going to have this open and closed curly brace. What curly braces does what functional scope refers to basically is the curly braces that follow a function definition. So in this case, we're creating this function called happy function, right? And we have an open curly brace after it and a closed curly brace on line 8. This basically means everything between lines 5 through 8 is part of this function scope, or the functional scope for this function. What that also means is this happy function has, within the confines of this particular function, we have access to every variable created in this function, as well as every variable created in its parent function, right? But if I have a variable I create here called message on line 6, guess who doesn't have access to it? Anyone who's not in my scope, or rather in the scope of the happy function, or one of my children's scopes, right? Because once again, my children, actually, I'll come back to the idea of like child versus parent later on. But here, if I define message as I am so happy, and I console log out message, I'm going to console log out I am so happy. But on line 11, when I try to console log out I am so happy, or when I try to console log out message, what do I get? Not quite.
No.
Nope.
Reference error?
Reference error, right? Because as far as like let's say I blurred out lines 5 through 8, right? And effectively, if you try to look at this code from the perspective of line 11, like lines 5 through 8 is like it's like someone else's sandbox, right? Like I can't see inside of it, so I don't know what's in there. So as far as I'm concerned, message is a variable that doesn't ever exist, right? If I ignore lines 5 through 8, nowhere on this page do I ever define a variable called message. And so that's why if I try to access something inside another function scope or inside another sandbox, I get a reference error. In this case, the reference error, you can't see it, it says message is not defined. Patricia?
So to fix that, would you just extend that, like move that curly brace down?
Yes, but more often than not, like we get this error is because you're trying to access something that you shouldn't have access to in the first place. Scopes are usually kind of designed with the intention of keeping certain things private. So if you're accessing them that doesn't exist, usually the answer is more like you move this inside here as opposed to you extend the scope. Because usually scopes are something that are designed for the very reason of keeping unwanted things out.
But I guess you wouldn't need to move that curly bracket because you want I am so happy, but it's already printed within that.
Right.
It's already on the screen right there through that first 5 through 8 line, right?
Yeah, but let's say down here I wanted to add another word to it, right? I am so happy today. How would I do that? And the short answer is there's not really a way to do that when you're outside of this happy function. You can only do it
You
inside.
have to do it inside, and moving that curly brace you said is not the good way.
Yeah, I mean, like you could extend the scope, but usually like the idea is like, I guess in this case it's more or less the same thing. But usually rather than extending the scope to encompass more things, you just put things inside the scope. Is probably the better way to think about it.
Outside in the global area?
No. More like if you need to do something to message, you do it within this happy function message function, right? You don't just make this like available to everyone. And we'll talk a little bit more about why global variables are incredibly dangerous, and very much like double equal signs. They exist, but we always go not to use it. We're using it as minimally as possible. Yeah, Rich?
I was thinking if, like, just for argument's sake, abstractly, if you were to want to have a function that produces a string message and then later add a conditional or add something, add like today, like
Yep.
plus string today, exclamation point, you could call the function with that added. Couldn't you do that, or is that inappropriate?
Well, so now we're kind of veering into like what return does, right?
Okay.
Because right now, what happy function does is it creates a variable, and it never really gives it to anybody, right? It never hands it off. And so this variable is really just created and then it's kind of used and then it's forgotten about, right? What you're talking about is, hey, let's access the variable when we try to use it. That will require us to actually be giving this message variable to whoever calls it. And that's where a return comes in, right? Like the point of a return is saying, hey, when I call this function, I expect something back.
Result.
I'm making a request, what do I get back? In this case, if I want to make message accessible for someone else who calls it, then I probably want to say, let's return the message. Let's give it to whoever's calling it. And now I have a copy. We'll talk about why it's a copy, but then I will have a copy of the string I can play around with.
That makes sense.
Oh, shoot.
What?
Dimitri, determine Dimitri. Yeah, you changed shirts. That was
So
off-putting.
if I declare the same variable in a global scope, if I do like a
We'll talk about that in the next slide. Yeah. About like basically you're asking like what happens if I have multiple variables with the same name that I create different scopes. Yeah, we'll talk about that in the next slide.
Everything that they said makes sense, but then how does invoking work in general? Because that is outside of all the scopes.
Well, not really, right? Because here, happy function, I'm on the global scope, right? This like line 10 is in the global scope. Where is happy function being defined? It's being defined on the global scope. So this variable happy function is on the global scope, and I'm on the global scope, and I'm just invoking it.
A function is a global scope automatically?
Well, a function can be thought about as a variable, right? Like so, oh maybe it's a hard. Like on line 5, we're creating this function, right? And this once we create this function, it means we can like this function is now essentially a variable, right? It's a variable in the sense that we can pass it back and forth, we can use it, we can do stuff, right? Like as far as I'm aware, happy function could be a number, right? Like in this case, it happens to be a function. So on line, because it's being created on the global scope, right? On line 10, we're just able to access that function like we would any other variable on the global scope. Now, if we create a if we create a function inside happy function, we would not be able to access it from the global scope because then that function or that variable is tied to whatever's inside this variable, right? So if message was a function instead of a string, guess what? We would not be able to invoke message.
You only
Right.
can invoke the parent function.
Yeah. We are able to invoke happy function on line 10 because happy function is being created on the same scope where it's being invoked, which in this case is a global scope. So another way to write, we'll talk about this in a little bit, but another way to write what we see there on line 5. Okay. So this function here that we see here, this is, I'll say like it's somewhat equivalent to doing, I think this, yeah, right? Like these two are the same things, lines 1 through 4 and lines 6 through 7, okay? And so the point here is that like they're both creating a function called happy function, and happy function basically is a variable. And the value of that variable is a function that does these things.
With parameters.
With parameters, sure, yeah, with parameters or otherwise. But the point is like happy function is just a variable.
Okay.
And so wherever the function is being declared, that's where that function can be invoked.
I guess I was just caught up by you saying that the curly brackets are sort of the compounds of the sandbox.
Yeah.
So
They are. So in this case, the curly braces attached to happy function means everything inside, everything between those curly braces are property only of happy function.
Okay.
But happy function itself is not inside any other curly
that's
braces,
true.
right?
Yeah.
Happy function is part of like the right. So like if you go in a sandbox, right? If I have a toy in a sandbox, like that toy may not be accessible to everyone in the park, but that sandbox is certainly accessible to everyone in the park, right? Like the container for that thing is available to everyone else. Okay. So to answer Dimitri's question now, right? What if a variable is defined really multiple times, right? As many times as we want, because there's JavaScript doesn't actually care. You can define a variable multiple times, and it's not going to, it's not going to penalize you. So on line 3, we have this variable called message, and we call it think globally, right? This message is on what scope? It's on the global scope, right? Because there's no open curly brace preceding it anywhere. Then we have a function called log a message. And on line 6, on line 6 we create a variable called message, and it's called act locally. On line 9 we console log out message. On line 12 we also console log out message. So what do we see here? Well, the first thing that's going to happen is, remember how we access variables, right? Or how we look for variables when we try to use a variable, right? Inside, so once again, we define a message on line 3. We define a function on line 5 through 10. But line 12 is where we actually invoke this log message function. If line 12 did not exist, there would be no output from anywhere else on this page because nothing else is being run on this page, right? Line 5 through 10 just defines this function. It creates a variable called log a message, and line 12 is where we actually do something with that function. In this case, invoking it. When we do invoke that function, on line 6 we create a variable. On line 9 we console log something out. And so this is like kind of like the most important part of understanding how scope access works, right? Like when I try to use a variable, I will always look for the closest possible value of that variable, right? What that usually means is I will look at my own scope first for the value for that variable. If my own scope does not have it, then I'll look my next layer out. If I'm in another function, I'll look in that function scope. If that function scope doesn't have it, then I'll look in that parent's function scope all the way until I get to the global scope. And if the global scope does not have that variable, then I say that's a reference error. This variable does not exist, right? So once again, when a computer looks for a variable, right, it's bad with ambiguity. It's very precise. It will always look in its own scope first, then it will look in the next closest scope, and then the next closest scope, all the way until I get to the global scope. And at that point, it will either give me back, I will either have found something, or I will throw an error back at you, right? So on line 9, when we console log out message, it will say, great, I want to use this variable called message. Do I have a variable called message in my own scope? And the answer is yeah. We define it on line 6. Great. I never look at the variable on line 3 because it doesn't matter, right? I've already found the variable message that applies to me. That's most relevant to me, and so that's what I'll be using in this instance. Does that answer your question, Dimitri?
Yeah, but I have more.
Sure. Okay, we have 2 more slides on this, so after these slides, I'll come back to you. Okay. This is very similar to the previous slide, right? Except the only difference now is rather than calling this variable message, we call it MSG. So basically, we create like a different variable, right? Now, when I try to console log out message on line 10 there, what it's doing is saying, great, you want to use this variable called message. Let's check. Do you have a variable called message in your scope? And the answer is no, right? Between lines 5 through 11, I never create a variable called message. So it's like, okay, great, you don't have a variable called message. Does your parent scope have a variable called message? In this case, the parent scope is a global scope. And is there a variable called message in the global scope? The answer is yeah. On line 3 there, we've created it already. So great. When we console log out line 10, we'll be using the variable message from our global scope. And that's why it prints out think globally. And then is there one more slide on this? Or yeah, no, there you go. Go ahead. Yeah.
That MSG is never used.
Yep, it's never used.
So what's the point?
This is more of like a teaching example, just to show you that like if we created a variable called something else,
Okay, so it's never used.
it's never used. Nope. Yeah. Okay. So what's question?
So on the previous slide.
Yep.
Go there. If I console log, after invoking the function, if I console log message is going to be the first one.
Sorry, say it one more time.
If I console log on line 13.
Yep.
The message is going to be the variable that I declare at line 3.
Yeah, exactly, right. Because if you're on line 13 and you try to get access to a variable called message, well, imagine lines 5 through 10 are blurred out for you, right? You don't know what's in there. So the only message variable you know about is the one on line 3, right? So at that point, it's not even a choice. You only have access to one variable called message. When you're inside the function, you have access to your message as well as the global message. But when you're in the global scope, you just have access to the global message, right? So you only print out the one thing you have access to at that point. Okay. So, okay, one more example, and this is something that I think trips up people up a little bit, is this idea of parameters. The way I like to think about parameters in most cases, so parameters are basically the things that are fed into a function, right? Like they're the things that are fed to a function, and ideally you're using those parameters to do something, right? The way to think about kind of functions and how they really kind of are treated in JavaScript is almost like, in this case, if I have a function called log a message, okay, if I have a function called log a message and it takes a parameter called message, you can almost think of this basically being created. Okay, that line 12 there. I've graded out to show that it's a comment. You won't ever see a line anywhere. But functionally, this, or rather, practically speaking, this is what's happening, right? Because I have a parameter called message, I'm basically creating a variable called message inside this function, and I'm assigning it the value of whatever was fed into it when this function was invoked, right? So because of that, if I go back to this slide here, and on line 9, I have a log a message, I feed in a string called act locally, act locally is the parameter here, right? And so between lines 5 and 6, you can think of it as almost like this like kind of pseudo line that says let message equal act locally, right? So on line 6, when I console log out message, the first question I ask is, great, is there already a variable called message in my function scope? And the answer is yes, there is. It was created when I made that a parameter. So therefore, when I log out message, I'm going to log out act locally, right? So just the TLD the more direct version of it is to say that parameters are also variables within your function scope. A function's parameters are also variables in the function scope. Yeah,
When
Shane?
I define it like you say let message equal message, you would say messages are already defined in the parameter. The error always comes up.
It messages comes up.
When you try and run it, it says the message
Right,
is
so-
already defined.
Right. So the reason why I have it commented out is because like you don't need to run that line. I'm just saying like as an example, like that's kind of what's happening like conceptually.
Oh,
Like this having message inside this parameter basically means you're creating a variable in this function called message, and the value of that message variable is whatever was passed in. Right. If you try to override it, it actually should work still. Maybe. Actually, maybe not. Maybe let only doesn't let you redefine variables anymore. But the takeaway here is just that like message is an actual variable now that exists within this function. This message here is different from this message here. In fact, they're completely separate. There's nothing. Even though they're called even though they're called the same thing, there's nothing linking them together, right?
So the console.log is not message; it's acting on the log a message log message.
The console log is being run whenever log a message is being invoked, and it's printing out whatever was passed into log a message. Right. So I guess to Patricia's example here, like this message variable on line 3 is never used anywhere in this code. It's just purely there to kind of illustrate scope. Amir?
So if you just do log a message but don't put anything in there,
Yep.
Would it be undefined?
Yes, because you would basically be saying, hey, log a message equals whatever was passed in, and if you don't have anything passed in, then the value is not assigned. So by default, the value would be undefined.
I was just thinking maybe just because it says message when you build the function, that maybe it could have been think globally.
Yeah, no. So the thing here is that like this is saying let message equal what was passed in, and even when you pass nothing in JavaScript, that's still like a value. Like an empty value is still a value. So like a null value or an empty thing is still undefined. Yeah. Tyler, your question or?
No, sorry.
Okay.
It was just,
Yeah, it looks like if you define a variable message inside the function, give it a value, it returns duplicate declaration
Okay.
error message.
Cool. Yeah, I mean we can test out pretty easy. So the idea is like, hey, let's actually do this, right? Let's do this, and let's say make this 1, 2, 3. I do this. Okay, I am declaring variable twice. Okay, yeah, I guess JavaScript doesn't let you override it. But then again, like this is just more of like the idea of what's happening by things, not the actual code that you're actually going to be running. Although this is quite surprising because if I do something like, oh, maybe this is something that's like, if I do something like let David equals 123 and then let David equals, okay, so let only lets you do something once. Oh, cool, good to know. I'm sorry?
With the same variable.
The same what?
Variable.
Same variable, yeah. So all I gotta do is if I just don't use let, then this works perfectly fine. But you can only, I guess let basically checks the scope, and if it already exists, it doesn't let you override it. I wonder if, we'll talk about what var is in a little bit, but I wonder if var also does that. No, so var lets you override it, whereas let doesn't. Okay, so we'll come back to like what var is, or what the difference between var and let. Okay, so parameters are locally scoped. Cool. All right, nested functions. Yeah, so this is kind of like, now we're moving into the idea where, hey, rather than just having my scope and my parent's scope, which happens to be a global scope, what if my scope runs infinitely deep, right? And really in JavaScript, you can create as many scopes as you want, as nested as deeply as you want as well, right? So in this case, we have a function called outer, which has a scope because it has a curly brace that runs from line 14 to line 12. Also, notice how I can very confidently say the outer function scope runs from line 4 to line 12. How do I know that? Because I make an assumption that the code is indented properly. So when I look at the alignment, this is a straight line. I can tell that this line 4 is to line 12. Any person who reads your code is going to have that same assumption. So if your code is misindented, like it does materially impact how someone understands and reads your code, right? So indentation, like it may be a trivial thing for a computer, but it's a very practical thing for a human, right? Similarly, when I look at this function here, I can tell that for line 7, the inner function scope runs from line 7 to line 10, because once again, that's how the indentations line up, right? So these are some of the people who read your code are going to make. Okay, so we have a global var, we have an outer var. Notice how we declared outer var here, but we run it on line 14, right? Notice how we declared inner function here, but we run inner on line 11, right? Once again, a function is not run just by being declared. A function is run when it's actually being invoked. And the invocation, you can tell, is from the open and closed parentheses, okay? So we have a global var called global, outer var called outer, inner var called inner, okay? Here on inner var, when I console log out global var, outer var, and inner var, well, I mean, you can see the output, right? And the short answer is, how do I get there? Well, so I go through this code, line 14, it's going to invoke outer var, or outer function. So I go back to line 4, I run through this. On line 11, I invoke inner, right? And then on inner, I console log out these 3 things on line 9 there. Global var, is there a variable called global var in the inner function? And the answer is no, there's not, right? Nothing here is called global var. So let me check my parents' scope to see if my parents has something called global var. Does my parents have something called global var? No, they don't have anything. Okay, great. Do their parents' scope have anything called global var? And their parents happen to be the global scope. So yep, the global var variable exists, and it's called global. When I print out outer var, is there a variable called called outer var in the inner function? The answer is no. Let me look at my parent scope, which is the outer function. Does outer var exist there? It does on line 5. And then lastly, for inner vars, do I have a variable called inner var? I do. Great. I can stop checking. There's no other need to because I already found it. And so when I print it out, I have access to all 3 variables, right? This is the idea where if you're like, so when I talk about child and parent scopes, like, I guess like the global scope will always be like the outermost parent, and then from the inner, and then if the inner function is the child of the outer function, and the outer function is the parent of the inner function, right? So you can think of it as a relationship, as like it's a family-based relationships. It's a family-based relationship. Similarly, if I have another example here, right? This is very similar to the previous one, except now the only thing that's different is rather than defining these variables explicitly, I now have a variable defined as a parameter, right? This outer function has a variable called collision defined as a parameter. So when I'm in the inner function, once again, I run down lines through this code. Between lines 2 through 12, like nothing's being run, so to speak, right? The first thing that gets run on the page is on line 14 there, where I call the inner function, and the inner function takes in a string called outer, and that string outer becomes this parameter called collision. And then on line 11, I actually run the inner function. And so when I run the inner function, doing that gets console log is on line 8 there. Console log says, great, tell me what collision is. Well, do I have a variable called collision in my own scope? And the answer is yeah, I do, on line 7 right there. It's called inner. So great, I don't need to check any other versions of collision. I have the version that I need, which is the version that is most closest or most accessible to me. However, if the variable collision didn't exist in inner var, on line 7 there, when we console log out collision, it will say, do I have a variable called collision? The answer is no. Okay, do my parents have a variable called collision? And the answer is, yep, your parents have a variable called collision. It was one of their parameters. And so what's the value of the parameter? The value of the parameter comes from that outer string on line 12 that we fed into the outer function. So when I console log out collision here, it should print out outer. Make sense? Yeah? Okay.
Sorry, can you go over one more time why it would be global?
Yeah, basically when I'm on line 7 here, when I'm trying to print out collision, right? I'm looking for a variable called collision. The first place I looked is in my own scope. And between lines 6 through 8, there's no variable called collision. So then I look at my parent scope. My parent scope runs from lines 4 through 10, yeah. runs from lines 4 through 10. Between lines 4 through 10, is there a variable called collision? And the answer is yes, there is, right? There's this parameter called collision, which becomes a variable in the scope. And so what's the value of this parameter? The value of this parameter is whatever was fed into the outer function. And what was fed into the outer function was this string called outer. So basically, I found my nearest version of collision, which was in my parent scope.
Oh,
Right. If this wasn't here, if this didn't exist, then I would say, okay, my parents don't have it either. Is there anything in the global scope? And at that point, I would go outside and look on the parent scope, right? But the idea is I've already found it on line 4, so I don't need to look anymore to get to line 2. I think that's the next slide, probably. Yeah, great. Oh, that's fast. Right, so in this case, collision, it's not an inner, it's not an outer. The only place that collision exists is on the global scope as a global variable. So by default, that's like the very last place we look, and that's what we use in this example. Okay, any more questions on function scopes? Yeah, Will?
So general idea is you can always access a leaves in your parent, but if you're only able to find it in your child, you get a referencer.
Yeah.
You can't look.
Yep. You cannot look in. You cannot look. You can only look up. You can only look in one direction, which is outerwards, like outwards, if you will. You can't look inwards.
Like nested folders in the directory.
What? I'm sorry.
No, it's like nested folders in the directories.
Right. Yep. The other thing you also can't do is you also can't look in like your sibling scopes. So like sibling scope, as in if I have like a inner 1 function here and an inner 2 function right beneath it, I can look at my parent scope, but I can't look in their child scopes too, right? Which kind of makes sense intuitively. You can only look in the things that you have access to or that are in your direct like lineage, if you will. And then this example is just to show you that, hey, on line 11 there, when I try to console log out innervar on line 11, I can't. Why? Because innervar only exists within the scope of this inner function, right? And if I'm in the outer function, I don't have access to anything that exists or that's being created inside my child function. So I can't look inside my child scope, my child function scope. Okay. The inner function will still look for a local declaration in the variable name before looking. Oh, I see. Yeah, this is basically telling you that, well, I guess this kind of brings back to, was it Tyler's question earlier? Of like, here we call inner, but we don't feed anything in. So outer var basically becomes undefined. So even though in this case, outer var is undefined, outer var still exists. And so when I print out outer var and inner var, I'll print out the undefined as opposed to the outer, right? It like outer var still has a value. The value is undefined. Does that make sense to folks? Look, folks, like on line 11 here, when I invoke inner function is supposed to take in something, right? And whatever it takes in, I assign a value to this variable called outer var. When I don't give any value, when I don't pass any value into this becomes undefined because by default, all variables in JavaScript are undefined if you don't give it a value. So even though outer var is quote unquote undefined, it is still a value, right? And so when I console log out outer var on line 9 here, the first thing it does is like, is there a variable called outer var in my own scope? And the answer is yes, there is. It was a parameter. Great. And what was the value of the parameter? The value of that parameter was undefined. Yeah, Tyler?
We defined outer var, like, again, let outer var equal outer in, like, line 8. Like, would that work?
Yeah, you just wouldn't be able to say let. You would just do outer var equals outer because in the parameter, outer var was already declared.
Okay.
Declare is usually used to the idea that you're creating a brand new variable. What you're talking about is more of a reassignment.
Okay.
Like, let's take the existing outer var variable and let's give it a new value. Yeah, Cheyenne?
So the outer var, the let outer var doesn't exist to the function below.
To the function below.
Why wouldn't it though?
In number 7.
Sorry, so Cheyenne. So in line 7.
Yeah, outer var doesn't. Number 5, line 5 doesn't exist to line 7. I mean to line 9.
It does, but when line 9 looks for outer var, it just looks for the nearest version first, right? So let's say you want to go to you want to get food, right, at a Chipotle or McDonald's, right? You go to the closest McDonald's first, right? If that McDonald's is closed, then you might go to the next closest McDonald's, right? In this case, outer var, the closest outer var we have access to is the one that's a parameter to us. So we'll just use that one. If that didn't exist, then we will go to the one on line 5. But the one on line 7 does exist, so we just kind of stop there. And we're like, great, we found an outer var. Let's keep moving.
If it's not stopping it working, it is.
So the way to make it not undefined would be to put a parameter in the inner.
Yep.
Any parameter would work.
Yeah, any parameter would
Just
work.
change the parameter from outer bar.
I mean, I guess the point here is even you know how 0 means no amount, but it's still a number, right? It's undefined means I haven't created value yet, but it's a very specific value. It's 0, right? It's it means there's nothing there, but it's still
It exists.
it exists. There's nothing there, right?
It's 0.
If your bank account has $0, you still have a bank account, right? So so all this is trying to show you that even when a value is something undefined, it's still a real value. So when we look up that variable, it's still gonna find that value. Yeah, Tyler?
If we were to just put x for on line 11 for the parameter inner, then it would become x, right?
Yep.
Next.
Yep. Well, it would print out x space inner. Yep.
You're feeding through.
Sorry, I think I'm just kind of confusing myself. The undefined
I
inner
literally have
is because of what you wrote on line 11, right?
I'm sorry?
That undefined inner in the corner
Yep.
is because of what you wrote on line 11.
Yeah.
Or
Mm.
line 22.
Yeah. So here. Okay. So here's a function, right? Let me just comment on everything else on this page. Okay. So this is the outer function, right? When I invoke outer, I get undefined, comma inner. If I make this something like x, I now get x inner. Because outer var is no longer undefined.
And so that outer at the bottom,
Yep. This is a function. This refers to this variable called outer, whose value is a function that we defined on line 18.
And it runs everything inside of itself.
Yep.
Which includes inner.
what is it? Did you see what that came up with?
I'm sorry, what?
Because I think what I'm understanding when I see x inner, it's because we're looking at what happens on line 23, but on line 25,
Line 23 is happening because of line 25.
it's inside, it's nested.
Right.
function.
Okay, so
Runs
let's
all.
delete everything on this page, right? So we start at line 1, okay? Lines 1 through 7 right now, as constructed on this page, does nothing. Right?
oh,
We create a function, nothing gets run. Line 8 is the first time we actually run anything on this page. And what we're running is this outer function, this function called outer, right? So line 8 takes us to line 1 and actually takes us inside this function scope. So what is this outer function doing now? On line 2, it creates this outer function, this outer var. And then on line 3, what it does is it creates another function called inner, right? But it never runs inner. Lines 3 through 6 are created. It never runs until we get to line 7. Line 7 is when we actually run this inner function. So after we invoke inner here, then this takes us back to line 3, then lines 4 and 5, right? So when we talk about where this console log comes from, the console log comes from us invoking inner. Inner is only run because we invoked outer, and outer is being invoked on line 9.
so there's no way to just run if you don't have the outer on line 9.
No, because the only place, if we're outside of the outer function, we can't see inside the scope of the outer function. Right? Like this we're talking about with scope, right? Like inner is a function that we've created inside the scope of this outer function, which means the only folks that have access to this inner function are things inside this outer function, as well as any nested functions being created within it. In this case, there's nothing else being created within it, So the only place we can access the inner function is within the outer function. Right? We have this nice little like thing here on line 7 that runs inner, but the only way we can reach line 7 is if we actually run this entire outer function code. And so that's why we had to run it on line 9 there. Cool.
I think I got it. I just have to just.
Cool.
My
Tyler?
question's related. It's like from a few slides before.
Yep.
It's like the let collision equal global slide. If you could pull it up.
Sure.
My question was, I'll tell you, there's a few of them, so I'll tell you which one it is. It's when we run at the end, outer.
Outer.
On line 12, we run outer, and then the parameter is also like text outer, string outer. Yeah, that one. My question is, when we call the outer, shouldn't the parameter take over the collision parameter in the outer function? Like,
Yeah, it does.
wait, this isn't actually it, it's the next one.
This one?
For me, like, I'm confused on why we get outer as a result here. Is it because when we run on line 12, we say outer, and outer then replaces collision on line 4? Like, because we're saying console log collision.
Right.
That's what I would like think we would be logging. But
So is your question why it's not global?
yes, I just don't understand why we get outer here.
Okay, so
Can you just walk us through like how
Yeah.
the process would work? Why it's the same way we like went line by line with the other one? Because this one
Sure.
didn't make sense to me at all. Thank you.
yeah, no problem. Let me just.
It's the same principle. It's just like the last time we had nothing in there, and then we put X in. But now there was
Okay,
nothing.
So for this function here, on line 11 we create a variable called global. On line 12 through 17 we're defining a function that we never run yet,
Yep,
right?
understood.
So until here nothing happens.
Yep.
Line 18 is the first time we actually run anything on this page, and we're running this outer function. So now we go back to line 12, right? Maybe the missing kind of piece for understanding this is understanding like here what we're saying is let collision equal outer.
Okay.
Okay.
Yep, got it.
So now when we run inner, it's going to look for collision. It's going to say there's no variable called collision in between lines 14 through 16, which is the first place it looks. Then it'll say, great, is there a variable called collision between lines 12 through 18? Oh, there is. And it's go to outer. So
my
that
brain was thinking just to skip above that because that one line was there, but that explains it perfectly. Thank you very much.
yeah, no problem. And then Will, do you have a question too?
Yeah, I guess you go back to the one we most recently were on.
Yeah, sure.
Most recent one. Just to confirm, if you were to
Oh,
change-
whoops. That's not there. This guy. Yep.
If you were to change line 14 to inner and call it inner, you would get a reference error.
Because inner doesn't exist on the global scope.
So that'd be an example of trying to go like downward.
Wait,
And you can't.
Can you repeat that? I didn't hear.
Sure. The idea here is nice. I didn't delete the code, so it's still there. Cool. So this is a code that we were just looking at, Patricia, for the previous one with inner x. Will's question is, hey, what if we made this inner? And I just tried to run inner without like running outer. If I try to do this, I'm going to get a reference error, right? And the idea and the reason for getting this reference error here is because on the global scope, there's nothing called inner, right? Inner is only created within the scope of this outer function. And remember, scope means you can look outwards to your parent scope, but you can't look inside someone else's scope. And so if I'm on a global scope, the only way I can kind of see this inner function is if I go inside the outer function scope, but I can't go inside someone else's scope. Right? So for all intents and purpose, on line 9, when I try to call inner there, imagine this entire thing is just blacked out. Like, I know there's a function called outer. It has something inside of it, but I can't see it. I'm not allowed to see what's inside of it. So when I try to call inner, as far as I know, inner does not exist. And so that's where this reference error comes from. You can't see it very clearly, but reference error, inner is not defined.
So you can grab it from the outside, but you can't grab it.
Right. You grab from yourself, you grab from your parents, you grab from your parents' parents, but you can't grab from inside, right? One analogy I used to give to previous cohorts, which was probably another equally bad analogy. It was like if you need money, like you try to have money yourself first, then you ask for your parents for money, then you ask for your grandparents for money, but hopefully you don't like take your money from your kids or like from your siblings, right? It's like there's like a clear hierarchy of like people you can ask for like things from. So in this case, like if you're trying to access something called inner, well, as far as you know, it doesn't exist. Yeah, I thought it was terrible, but
No, I just use it too. You should leave with that.
if it works, I'll keep writing that analogy. See how far I can take it. Well, because then it also makes it sound like like
Or you have cousins too.
you just ask parents for money,
That's like sibling level functions would be like cousins.
Right. So you basically are only allowed to ask your parents for money. Right. Right. Okay. Cool. So that's function scope. We have this lecture is taking a while, which is good because people. It's not because of me talking. It's because there are legitimate questions. But so this is function scope, right? Everything we've talked about so far has to do with the curly braces around functions. JavaScript also has something else called a block scope. So where else do we see curly braces in JavaScript?
Between for loops.
For loops. Where else?
If statements.
If statements. Where else?
Function.
Well, function. Yes. Functions. Yeah. We already talked about function. What else? Where else do we see?
Switch statements.
Switch statement. Yeah. Where else do we see it?
Classes, software.
Classes are a bit different. Classes are essentially functions in some ways. But like yes, but we also see them there, right? We also see it in while loops, and we also see it when we make objects too. For the purposes of talking about scope, the ones we want to focus on are if statements, while loops, and for loops. And so, if I have an if statement, right, and I have my conditional, afterwards I have an open and closed curly brace. In JavaScript, this also creates a scope. It's not a functional scope because it's not a function, right? What it is we call it a block scope, right? So it's like, here's a block of text. It's not a function, it's just like a block of text, right? So here, when we create a variable called Jenny from the, and then we console log out block and then comma then block, this will actually print out the entire statement, right? However, the same idea applies, right? With any idea for scope that you can always look outwards, you can't look inwards. So if I'm outside of this if statement, and I try to print out this variable called block, well, guess what? It doesn't exist, right? Because as far as line 9 is concerned, everything inside this block scope is opaque. It's not there, it doesn't exist, I don't have access to it. And so this basically tells you, in essence, like in terms of permission and access, a block scope operates very similar to a function scope. And this also kind of hints at why ES6, or why we see people use let now as opposed to var, right? Previous to ES6, so in ES5, var was kind of the default way to use to create variables, except var didn't adhere to this idea of block scope, right? There was no block scope in ES5. So basically every variable that you created with var, whether it would be in the if statement or a for loop or a while loop, it all got assigned to the scope of the function that it was in. Let basically says, let me look for the nearest scope, whether it be block or function, and let me attach it there instead. So basically let is a more refined, a more precise way to create variables, and that's why nowadays it's like the default way in JavaScript to create variables, right? Is because you want to kind of hold on to this idea that, hey, wherever I create a variable, I'm creating it there intentionally because I only want it to be used there, right? So if I was to go back to ES5 days and say, if true, let's create this var block, well, guess what? This block is now attached to the nearest function scope. Well, there is no function, so then by default it gets attached to like its parent scope, which is a global scope. And now everywhere else on the page, I will have access to that block variable, right? So it's a lot more like easy to use in terms of it's accessible to everyone. But in computer programming, and especially in terms of software security, usually that's an anti-pattern. You don't want to create things that are accessible to everyone. In fact, in the majority of cases, when you write software, you actually want every function, every piece of software to have access to the bare minimum that it needs to do the job, and no more than that. So that's why we use var now, that's why we use let now instead of var, is because var ignores block scope, whereas let treats block scope like it does a function scope. Yes, Claire.
Does const follow the same.
Const follows the same rules as let, except you can't reassign const after you define it.
Is the if statement a function?
No.
It's not.
If it was, it would be a function scope.
Yeah.
It's his own function.
Because it,
but it's
cause
its own
it,
scope.
it's dressed up kind of similar way. You got the parentheses and the curly braces afterwards.
Kind of. Well, so the like functions, like the main difference is not kind of how it looks, but how it's used. Functions can be passed back and forth, and it can be used by different parties. If statements only work where it's declared. Like I can't take an if statement and say, hey, I wrote this really nice if statement. Do you want to use it in your code too? Like there's no way to transport it. So I would say that's probably the bigger difference between functions and ifs, is that functions are reusable, if statements really are not. And neither are for loops or while loops.
Those would have to be like packaged.
You would need to pack it inside of a function, pass that function back and forth, and then use it. So the portability is probably the bigger difference between functions versus other things. Yeah. Anything else around block scopes? Right, like semantically very, very identical to function scopes. The only difference is this is where the power of let and const kind of really shows an advantage, if you will, over var. But this also hints at another problem, right? If you want to, if I go back to the previous slide, actually, yeah. So if I run this code, right, it's like, hey, if block exists, like console log out block, right? Or sorry, if this is true, create block and we'll console log it out. Well, you know, let's say this wasn't just always true. Let's say there's a chance to be false too, right? If I console log out block, well, there's a chance I could get a reference error every time, right? So what this means then would be that like, hey, I need to be really careful about where I create my block variable, right? If I'm creating it inside here, I can't let anyone else use it. If I want to make sure that this will always print something else, I need to create this at a place where block is accessible to line 9. So in this case, I'll probably create block on line 3 and then reassign the value on line 5 if it's true. Otherwise, I would keep it at a default value.
How would you reassign that?
Yep. So let's say like nope. Okay, so let's say this is oh gosh, what's going on here? Whatever. Okay, so let's say this is my current code, right? Okay, so let's say this is my current code, and right now when I do it, I get a reference error saying block is undefined, right? If I want to make sure something always prints out, like let's say if something is false, I wanted to create out, you know, like node text, right? What I would do is I would actually define it. I would say let block equal like no text. And then if I do it this way now, I will either get one of two possibilities, right? If it's true, then block, the value of block will be overridden with Jenny from thee. And so on line 6, when I print it out, I get back Jenny from thee. On the other hand, if I, actually, let me see that. On the other hand, if this is false, then I get no text, right? So this is like the idea where like, basically now what I'm doing is now I'm creating this variable called block at a place in which this will always be able to access it. The only difference is if this is true, then I just overwrite the value block with something else. Otherwise, I print the default value. So this will make sure I never get a reference error. Right. You seem a little bit confused though. Right, so, okay. So let block go this right.
True means that you'll just go inside that.
Yep.
Or false, you would never go inside it, which is why you would skip it.
Yep. So if this is true, right? If this is true, I go into line 3, I create this variable called block, right? And guess what? Do I have access to it on line 5? No. No, because this is inside the block scope of this if statement, right? But what if I did want this to print out whatever this value was? Or rather, what if I didn't want this to error out, right? Like what if this was false, but I still want a block to have a value? How do I do that?
I get that you go outside, but you have the no text right there.
Yep.
And so why wouldn't, how are you allowed to pull Jenny from to the outside?
Oh no, sorry. I still wouldn't be able to pull Jenny from D, but this at least lets me create a variable that then doesn't error out when I get to line 5. Wait, sorry, what am I doing here? Oh, sorry. My bad. I was thinking about creating another let here. If I do this, then I will never get Jenny from D. If I delete the let, what I'm actually doing here is the variable is created here, and here I'm just changing the variable. When I get down here, the value, like this block, remember, you notice how this block has no let before it? Which means it was not created in this block scope.
It's just being renamed.
So therefore, it's not tied to this block scope.
It was just kind of defined, and now it is what it is.
Yeah,
if it's
so-
defined, that's why you get the-
Yeah, so if I go into the slides really quick, I'll come back to the thing, right? We skipped over this part really quick. But on the very first slide, right? Actually, yeah. The location at which a variable is declared. The location when a variable is created, that's when its scope is determined. Right? So where we create the variable is how we figure out what the scope is. And so when we go back to our text here, right? Where is the variable called block being created? I'm sorry?
At the top.
On line 1, but what scope is it being attached?
Global.
Right, it's being attached to the global scope, right? So on line 3, I could edit that variable all I want, but the variable is still where?
On the one.
On the global scope.
So once you edit it to Jenny from, it will always be, it will not go back to no text.
Yeah,
Once you go further on.
Yeah.
Because you've changed it, and now you've changed it, and because like can be changed.
right. The point here is that scope doesn't actually matter anymore because scope only matters at the point of creation, and it was created on the global scope. Now, the example what I was saying earlier about it never being true is if we do something like this now I will never be able to get Jenny from D outside of this if statement because guess what I'm doing? I'm creating a new variable called block, and because scope is determined at the point of variable creation, this block is attached to this if statement, right? So I can never get access to this variable if I'm outside of this if statement. So in this scenario, it would always be no text. But if I just say, hey, I don't care about creating a new variable, I just want to update my existing one, now I have access to it like I do any other common variable.
Thank you.
Yep. Cool. So where were we? We're almost done here, right? Yeah. Okay. So that's block scope. ES6. Yep. We ignore var. Okay. And so this is the last thing I'll talk about here, which is this idea of hoisting. Remember how I said earlier when JavaScript looks at a piece of JavaScript, it kind of reads it almost twice. The first time it just kind of makes sense of it makes an inventory list, I guess, of what's available. And then the second time it actually goes through, assigns values, runs code, does all of these things. One of the things that I showed earlier was, hey, there are two ways to create a function, right? The first way is to do function name parameter, right? The other way is to say like let or var, name equals function parameter, right? You guys remember this like 20 minutes ago or 40 minutes ago, unfortunately. So they're both equally valid ways of creating functions. The only difference there is in this case, when I created this way, which is declaratively, when I declare a function this way, what it does is it lets JavaScript pick up the fact that this is a function on the first pass through. So here in this piece of code that we see here, right, on line 4, I'm invoking this function called will this work. The first time that JavaScript passes through this, what it's going to say is, okay, there's a function on this page called will this work. The second time it goes through it will actually invoke that function, will this work. And so this is why we're able to invoke a function theoretically before it's declared on the page. Okay.
What's the real world application of that? Why not always declare it before?
Yeah, we'll talk about that in just a little bit too. I'll come back to that in a little bit. The other way to declare a function is this, right? Wait. This is not right. Function expression can only be run after the line on which they were defined. Oh, sorry, this slide is not correct. I'm sorry. This equals Actually, let's just copy this. This should not be. Unless I'm wrong about this. Okay, yeah, that's what we should be getting. Sorry about that, guys. In this case, if we define a function this way, like let variable name equals function, if I try to invoke, if I try invoking it before this declaration, this will work, right? Because on the first path through, all JavaScript's going to say is, hey, there is a variable on this page called will this work, and its value is undefined. The second time it goes through it, it will try to invoke the function. Except, what error are we going to get there? The error that we end up getting is, will this work is not a function yet, or more like probably more precisely, the error that's getting is trying to invoke this thing, except this thing is undefined, so it can't invoke it. So that's why I'm saying, hey, because I can't invoke it, I can tell you this is not a function. Remember, JavaScript will try doing what you tell it to do until it fails, right? So this error is basically saying, hey, I tried to invoke it. The only things that can be invoked are functions. So if I can't invoke it, then it means this is not a function. So this is like the kind of the difference between declarative versus expression.
Would it make any difference if the function on line 1 was declared after, like on line 5?
If the function on line 1...
After the definition of the let will this work equals function, if you call the function, invoke the function after the line 5, does that make a difference?
Yeah, no, this will not work. Okay. Yeah, this will not work, right? And so the point here is just to show you that this is one of the reasons why people always say like put your variables at the top of the page. The two reasons for that are, one is because everyone can kind of see what you're going to be using throughout the course of your code. And the second reason is you avoid scenarios like these where you try to use something before it gets created, right? Because if all the variables are very top, anytime you use it, by definition, it must have already been created and assigned. And
so that works. Okay.
Yeah, so this works. So in terms of kind of why you want to use one versus the other, actually, let me see if there's like a list. I'm sorry. So JavaScript, it's expressive versus declaration. There are some reasons for using expressions. I remember reading through them once, but they were like almost like very like edge cases that like I just didn't quite remember. So I just want to look through this, make sure I tell you the right thing. Name func. Why use function expression? No. Okay. Okay. So the three reasons they gave here are using it expressively. So using like let x equal function is better for closures, for arguments of other functions, and for immediately invoking functions. I would say that I don't actually quite understand. Like I'm not quite clear on the first two, but for the third one, this is something that we'll talk about more in like the full-time curriculum. But a lot of times, what you actually want, there's something called IIFEs. IIFE, which stands for immediately invoked functions. And what those functions are is as soon as the function is defined, I also want you to run it right away, right? So a lot of those are kind of more security-based things, right? Like as soon as the page loads, I want you to get the password or username, right? I want you to fetch someone's data. And so to capture the output of that, you can only do it through a declaration as opposed to you only do that through an expression as opposed to a declaration. But like I said, like those are kind of like very, very specific use cases. And so for the purposes of this class, know that there are multiple ways to define a function. If you use declaration, you'll be fine like for all of the workshops that we do together. But in the real world, there are certain scenarios in which an expression works better than a declaration. Yes,
What's the,
Emily.
you know, you can, I don't know if it would be very function, you could do a const, then maybe whatever your name function equals the argument, and then equals bigger sign. What is that?
I have no idea. If const variable equals,
Const and then the name of the function
okay,
equals, and then the parentheses and the arguments, and then the equal bigger sign bracket.
bracket.
You can define functions that way.
They,
With the little arrow.
sometimes.
Oh, you mean like oh, not bracket.
I mean, yeah.
Gotcha. Okay. I know what you're talking about. Sorry. You're basically saying, did I share this already? If not, you can have a random list of our musings. Okay, so we're talking about is like if I try to create a function that comes log out high, it's gonna do something like let David equal this. No. I don't even need that. Oh, right. This, and then I guess I don't need to return anything, so it'll just be a console log. Or actually, I'll just return high. So this should work. Oh, haha. I never invoked David. I just created it. Great. Okay. So this is called like arrow syntax. It's a shorthand at ES6 for making a function. There's nothing that this does that you can't do with a normal function. This is just like a shorter version to write it. I would almost say like I'll talk about it on the last day as kind of like a nice to know, but I don't want to talk about it too much right now because I feel like doing it this way is gonna make it like it's shorter, but it's also more opaque. And so because of that, when you do the workshops, I don't want you to get hung up on using this as opposed to kind of focusing on like the raw ingredients of the functions. But just know that there's nothing you can do here that you can't do with a normal function.
Do you see this expression in the real world often?
Yes.
Yeah, that's what Elliot's solution videos does.
Yeah.
Oh, he does?
Yeah.
Crap.
That's why the first lesson's like let this, let that. He starts a variable with the
Oh,
arrows.
I'm really sorry for that then.
Whatever.
I'll ping him about that. I mean, I'll just do a quick 5-minute primer on this. The time's getting tight today, but whatever. You're all learning, right? So that's what matters. Okay, so what this arrow function does is, or rather, so this function does this. The other way to write this function is if I do something like this. So these two are synonymous. Return high. Okay. So lines 1 and lines 3 through 5 are synonymous. And you have access to the REPL link if you want to copy this. But what this first thing does is saying let David, right? So that's the name of my function. Okay. I'm creating a variable called David. I'm creating in both cases here, even though line 3 it's not explicitly said, but it's basically what's happening. In both cases, I'm creating a variable function name called David. This is setting it equal to, and this open and close parentheses is basically a way of saying, hey, this is going to be a function, right? Because naturally speaking, like, or rather, this open and close parentheses plus this arrow function basically says I'm going to make a function. This is basically representative of the parameters that goes into the function. So if I have something called here like, hey, I want to make a function that takes in param1, comma param2, all I got to do in here is do param1, comma param2, right? So that's like the equivalent part. So this is saying what goes into the function. The arrow function basically says, okay, I've now saved myself the trouble of having to type out the word function, pretty much, okay? And then here, let's just make this a little bit more clear. Hopefully Elliot does this. If he doesn't, I'll actually be really excited. Let's put the open and close curly braces there too as well to set it up. And then within this line of code, we'll actually do whatever it is that we normally write in the body of the code. So in this case, we'll say return high. Okay. So now these two lines are pretty much like, so now lines 1 through 3 is pretty much equivalent to lines 5 through 7. The only difference here, literally, is we saved the trouble of having to type the word function. There's also a few other kind of savings that we have here as well, in the sense that if I want to just return something directly, a lot of times I can just like even get rid of the curly braces and just kind of go straight to this. And without any curly braces, this basically just, in JavaScript terms, this is like shorthand for saying just return whatever you want directly. But you can feel free to add in the curly braces too if you want to make it more visually kind of, consistent with what we've seen in other functions. So that's what that does. The other thing that arrow functions also do is it maintains the context of something called this. But I definitely don't want to talk about this just yet. Like, this is like a super, super confusing thing that messes up like very experienced people too. And for our purposes, it's going to do more harm than good. So there are like some like fringe benefits of using an arrow syntax. But once again, from a functional standpoint, it offers nothing that you cannot replicate yourself with a well-written out function. So for now, let's just do like a well-written out function. If at any point Elliot uses an arrow function and he does something really crazy, like I don't understand it, like let me know, I'll rewrite it through a more traditional function syntax. Yeah, Patricia?
Why do you have the semicolon after the curly brace on the first example? After the return high semicolon.
Here, on line 3? I guess I don't need it.
Oh, do you need it after the high?
Well, so so this is like one of those things. It's like, so the dirty secret is you don't need any semicolons in JavaScript. Like JavaScript will run perfectly fine without any semicolons. Semicolons, once again, are a convention for humans. It tells you when a line ends, and more importantly, to a computer, sometimes it is actually useful to a computer because it tells you when a file ends. Otherwise, a computer can't. If you're loading multiple files up in the same place, it's hard to tell like when one file ends and another one starts. So semicolon does that too. So because of that, I guess semicolons are like a preferred use case. But if you don't use it, JavaScript will run perfectly fine. It's kind of like white spaces and stuff like that.
So if you had it after the high and if you didn't, then
Yeah, it makes no difference in these examples here. Yeah. Yeah, Cheyenne?
So you don't have to invoke it. Then what was the purpose of it? Of invoking it, putting the function name if there's nothing there and it still runs.
Sorry, I'm not quite following.
You didn't have to put the invoke. You didn't have to invoke it.
Well, right now, like nothing's running. So,
Um,
so yeah, I'm not invoking it in lines 1 through 3 or 5 through 7, right? Like,
I remember doing this exercise, and I don't remember invoking it at all in any of the actual exercise we've done.
That's because you're not invoking it. The test is.
Oh, okay.
Right? When you run 4 different tests, and each test, the test is saying, if you run a function called only odds, the test is saying, invoke only odds, feed it these numbers.
Oh.
And here's what you get, right? So it does that for you. Yeah. If you look on the test, like, you'll see, like, functions always have to be invoked. Otherwise, they'll never, ever run. There's no syntax shortcut for that. Yeah. But yeah, if you guys see anything with Elliot in terms of like, hey, he's using like a new thing that I don't understand, like let me know. And worst case, I'll translate it back to something that's like more kind of day-to-day approachable for us. Yeah, Dimitri?
I'm assuming we're going to be looking at arrays today, later, right?
Later today, yes.
Okay. Because there was like something in there like
Cool. Yeah. Okay. Great. So so that's function and hoisting. That's pretty much it. Okay. Best practices. This is basically the main reason why we say, hey, you should never ever use, or rather, you should very, very rarely use global variables, is because if you use a global variable, you have no idea who else has been playing around with it, changing it in the interim, right? So here on line 1, we declare a variable called always true equals true. Guess what? In the middle, we have a function called always true equals false, right? So on line 10, when we use always true, we actually have no guarantee that always true is still true, even though that was the initial value, right? I'm sure there's like a really bad analogy I can make for this, but hopefully everyone gets the point, right? So like if you have a publicly accessible thing, it means everyone can use it. So when you actually use it, you have no idea what it is anymore. And so from a practical standpoint, it's dangerous. And obviously, if you're writing code, in a live environment with a lot of multiple users, like you also don't want to do that either. The other reason why, or rather, the way to get around that is, hey, whenever you're using variable, even if it happens to be named the same as a global variable, just create your own version of it, right? Kind of like how we did it for block earlier, like just create your own version of block, and that will get around it.
What if you created a global variable with a const that can't be changed? Does that change the?
Yeah. So
It's not good practice. I get it.
no, and the reason why is because what const prevents you from doing is reassigning things.
Right.
It doesn't prevent you from editing things that are inherently editable. So if I have const, I have an array of 3 things. I can keep adding things to that array because I'm not reassigning that variable. I'm just modifying something that inherently is able to be modified. Right. So const is not a foolproof way to get around global variables. Okay. So the other reason why you don't want to use global variables is because hey, like if you want to use something called, if you want to create a global variable called x, someone else is probably going to create one too, right? And so you're like using like a very, very publicly available name that other people could override. So ultimately, it all comes down to the same idea, which is when you use a global variable, you have no security that no one else is using it but you. And usually with all variables, you want to make sure you're the only person using it, or rather, only the people you want using it are using it. Cool. So that was pretty much it. Any questions?
Could you very quickly just give a definition of hoisting?
Oh gosh. Yeah. So I guess like the English definition of hoisting is like you raise something to the top, right? And so the reason why we call it hoisting in JavaScript is the idea that like when a computer passes through the code the first time, it basically almost like conceptually it takes all the variables and puts it on the top of the page. So that when it runs through it, it already knows kind of what exists and what doesn't exist. So that's why we call it hoisting. There's probably a more technical definition for it somewhere. But for this class, like usually we try to err on the side of like telling you like what you need to know. Because we don't want to overload you with too much minutia that doesn't really help you until you're like much more further along. So for now, just think of hoisting as the idea that like every variable that's being created on this page is brought up to line 1, and then the code runs as normal. Yeah. Cool. Anything else? All right, great. Running low on time, so what I'll do is I'll start the workshop now. Get lunch whenever you want, like whenever your partner feel like getting lunch. But I'll probably kill this workshop at like, let's say it's around 12:30. Let's kill it at like, let's say 3, and I'll start the lecture on the arrays at 3 o'clock. Cool. So I'll send out pairs, and then from now until 3, use your own discretion to figure out when you want to eat lunch, when you want to work on the workshop. Cool.